Nine. No, I really like you people, so I will not speak in German at all or attempt to do so. It would be just terrible. You're very welcome. So first of all, I must be sure to work out why my clicker is. I want to thank, in particular, Renee and Max and Vian, who made it possible for me to be doing this. Not just here, but all the way through Germany. And I'm really excited to be able to do this, and I'm delighted to be able to do it, and I'm very, very grateful for the opportunity to do so. And the main reason is because I love Perl. I love the community. I don't love my clicker. My clicker is dying. Yeah, I've got another one here too. I don't want to be messing around the whole time for you. Let's just switch out the batteries and see if these ones work. Yeah, they're much worse. Hang on. Oh, no, that looks better. That looks better. Yep, okay. So, I love Perl. I love the community. I love Perl 5. And of course, I love Perl 6. But love is a complicated emotion. It's never simple. Because I also hate Perl 6. And the reason I hate Perl 6 is how it makes me feel sad about Perl 5. So, whenever I'm asked to describe what Perl 5 is like, I always say it's a bit like Liam Hemsworth. You know the actor Liam Hemsworth? Okay, so he's a reasonably capable, reasonably powerful, workman-like actor. Doesn't look too bad. He's okay. You see him, you think, yeah, that's pretty good. And then you meet his brother. Yeah. And his brother looks like this. And that to me is what it's like when you go from Perl 5 to Perl 6. So I'm still not happy with this. Let me try something magical here. So here's some Perl 6. Simple bit of Perl 6 code. We declare a new kind of class. That class has, this thing is just not happy. Hang on, let me try everything we can. That class has methods. The methods can have arguments, and the arguments can have types. No, it seems to be okay now. I think we might have fixed it. But thank you. Good idea. And you can declare attributes of the class just by writing has and the type and the name of the attribute and some interesting characteristics to the attribute. The attributes are variables. The variables get to be used directly in the methods. So you don't have to be calling methods to get attributes all the time. It's very clean. It's very neat. It's very efficient. And then you compare it with what it is in Perl 5. Let's do exactly the same thing in Perl 5. And you get this. And there are no special keywords. You just have to reuse all the existing keywords. And there are no real objects. You just have to have classes, have hashes with special characteristics blessed into them. And most of the things that annoy me about Perl 5 writing classes is that the vast majority of the code is not actually doing anything useful for you. We call this kind of code in general infrastructure code. That is, it's not solving your problem, it's solving the problem that Perl 5 doesn't have real object orientation. Now, of course, the day after people realized this, they started writing modules to fix it. So it's not fair to compare this basic simple Perl 5 code against something like Perl 6, you would reasonably say, no, what I would do is I would use something like Moose, or one of the other 5,000 frameworks that you could use to do this with. And then, of course, the comparison is a bit better. There's much less code here, and it's more declarative. You have your has, and you have a kind of a type system associated with it. But you're still accessing the attributes of an object repeatedly. So it's not exactly fast. You end up still with twice as much code, and it's still twice as hard to get it right. And this is why I am annoyed with Perl 6. Because Perl 6 makes Perl 5 feel like Perl 4. For those of you who don't know, this is the third Hemsworth brother, who is definitely a robot. There's no question about that. That's not a real person. So when I'm coding in Perl 5, really all I wanted was 3 little words. Words like Perl 6 has. And I mean literally like Perl 6's has keyword, and class, and method. And so I say to myself, well, how hard could that be? How hard could it be to give Perl 5 all of the object model and syntax and API that Perl 6 has? And it turns out that it is a little bit harder than solving a Rubik's dodecahedron, but it's not as hard as successfully rebooting the Fantastic Four franchise, which apparently is impossible. So in other words, it's not really very hard at all. And the way we solve this problem of not having what I want in Perl 5 is the way that we solve every single problem in programming, which is we simply add one extra level of indirection. So what I wanted was to be able to write effectively the same code in Perl 5 that I'd been writing in Perl 6, with the obvious differences of arrows instead of dots and little things like that. So what's my one level of indirection? I wrote a module, as you do, and I modestly called it Dios. Not because that means God. Declarative inside-out syntax. So how do I do this? Very easily. From Perl 5.12 onwards, we have had the pluggable keyword mechanism. And if you go and read the documentation on the pluggable keyword mechanism, which is not easy to find, let me tell you, but if you do find it and you read it, then they tell you this: you simply implement new keywords in C. Which, in the words of the great Will Smith, oh, hell no. So fortunately you don't have to, because someone wrote a module called Keyword Simple. And the Keyword Simple allows you to create new keywords in Perl by using Perl. And all that you do is you install a callback into the parser effectively through an API. And whenever the parser encounters something that looks like a keyword but it doesn't know what it is, it goes and calls the callback for you. And what does it do? It takes all of the code in your file that hasn't yet been parsed, and it passes it to the callback. And then the callback's job is to extract from that code all of the components that make up the syntax of your keyword, and then replace the trailing code with whatever source code that you want to give it. So in other words, using this mechanism, you get something in $_, and whatever you leave in $_ becomes the new source code. So it's kind of like source filters, but not insane. because the parser is in control and tells you when you're going to do something. So what does that look like? What would the code for that look like? Here is the DOS module as implemented using keyword simple. So you created an import subroutine. So when you load this module, DOS, it does the following. It calls the define function out of keyword simple. You give it the name of the new keyword that you want it to detect, and then you give it a subroutine that tells it what to do when it detects that. And what it's going to do is pass you a reference to a string, and that string will have all of the trailing code that it found after the method keyword. And then you just do these simple things. Well, the first thing I'm doing here is I'm saying take the trailing code and remove from it whatever the name of the method I'm declaring is going to be. So I've made a regex called name that matches the name of a method. So I extract that, and if I don't find it, then I kill the entire process saying, I expected this, you didn't give it to me, you must die now. So I extract that, and that's the easy bit done. Because the next thing I have to do is extract any parameter list of the method and then extract the block of code from the method. And for that, the only way of reasonably doing that is with PPI. You know PPI? Yeah, amazing effort, despite being done by an Australian criminal. So I take the rest of the trailing code, I make a PPI document out of it, and then I start traveling through the document. I have to go down a couple of levels because that's the way PPI structures the document analysis. And I say, all right then, the next thing I'm looking for is a list. If there's not a list, well, they didn't give me a parameter list, so I'm just going to skip over that. Otherwise, I'll take the parameter list off the PPI document, so it's removed from the final code, and I'll remember it somehow. And then I'll do the same with any attributes, colon whatevers that I needed to deal with. So I go through and look for that, and I'm going to simply go through until I find the block of code that must be following this. We hope. It might not be, in which case things are going to go horribly wrong, but we do our best. So I just keep removing attributes as long as I can, and then I find my block of code. This must be my block of code because I only jumped out when I found a block of code. So if it's not a block of code for some reason, throw an exception and otherwise remove the block of code. And now I've extracted my parameter list, any attributes, and my block of code after the name of the method. And all I do is I take the parameter list and I somehow convert that into the kind of Perl 5 parameter parsing mechanism that we're all used to. I'm not going to go into the details of that, it's not really interesting. And I remove from the block the curly brackets around it, just so I've got the block contents. And then I make some new trailing code, which I put back into the trailing code variable. First of all, I say sub, because that's the only built-in Perl name for this. The sub name, the attributes, whatever the parameter setup I created out of the parameter list was, plus the block contents in their own block, and then I put the rest of the parsed code at the end of it. And then I put it back into the original variable that I was passed a reference to. And that's it. That's all you have to do. There's the whole thing together. Now, the thing I hate about this is that this is almost entirely infrastructure code too. The only bits of this that actually refer to what I was doing to convert a method declaration to a subroutine declaration are these lines. They're the only lines that are actually doing the job. The rest of it is just infrastructure code for one keyword. But I want 3 keywords, so this is what I get. 107 lines of code, 80% infrastructure.
I guess it's still faster than Perl 6.
So my problem is basically with the name simple. I don't think that word means what you think it means when you call this keyword simple. So what do we do when the tool for building other tools isn't sufficient? You know what we do. We build a new tool for building tools. But you know what? That's always a waste of time. You're better off doing one more layer of indirection and building a tool for building tools that build tools. It's a much better solution. So that's what I did. I added one more level of indirection to this whole thing. And I said, all right, I have to deal with keyword simple, but no one else should have to deal with keyword simple. So I'm going to use keyword simple to create a meta keyword. That is a keyword that declares all other keywords. And if I take that load off, then everyone else gets life being easy. So what will I call that keyword? Obviously, I will call it keyword. And what will I call the module that provides it? Well, I thought about keyword. So good they named it twice. And then I thought that doesn't make, no one knows what that means. So I thought maybe keyword Kafifi. It would make it very easy to search for. And finally I decided I'd call it keyword declare. So I wrote a module called keyword declare. And with keyword declare, you use the module and then you get a keyword. And what do you do with that keyword? You tell it, here's the new keyword I want a debug keyword. What does that keyword take? It's followed by an identifier and then a block. I give you variables, parameter variables, which that identifier substring and the block substring will be placed into. And then all you have to do is make your code into a string which you return. So literally, I'm just going to say, all right, every time I see debug something, replace it with a warn with the ID immediately afterwards, and then a call to data dumper dump on whatever the block executed. So execute the block and then dump the result of the block. That's what debugging means. So that's the code that will replace any occurrence of debug identifier block. And you just return that string and the keyword takes care of it all for you. And then you get a debug keyword. So the question is, how does this keyword actually do the magical keywording? And of course, it's just a wrapper around keyword simple. I wasn't going to re-implement everything. It was all there, just no one wanted to use it. So all I had to do was make something that would integrate both PPI and regexes to parse Perl. And how hard could that be? Plus I thought I'd better have a multiple dispatch mechanism, because you might want to have two different keywords with the same keyword but different arguments. And you want to have two of those. So that was going to be really, really simple. Maybe. So here's the whole thing. You use keyword simple, you use PPI. You define the keyword. Question? Oh, I'm sorry, you don't know PPI. PPI is a module that takes a string that's supposedly Perl code and gives you back a parse tree of that Perl code. So, here's what we do with it. First thing we do is we make a PPI document. This is the line that is taking the source code and giving you back a parse tree. Then we have a function that simply says, okay, extract from the parse tree whatever they said the appropriate things were. So here I want to extract the name of the keyword, the list of parameters of the keyword, and the block. So this is kind of an example of eating your own dog food. This is what the actual code uses to do its job. So I thought, well, the module should use it as well. So we extract from the parse tree all that information, and that then gives us the name of our keyword, the parameters of the keyword, the block of the keyword, and it also returns the trailing source, which we have to put back somewhere. So we get those back and we use them to build an implementation for the keyword, which again I'm not going to bother showing you. It's not interesting, it's tedious, which is why it's hidden away in a module now. And then you just do the following. Instead of the keyword, you put this in, a begin block, which is the moral equivalent of an import subroutine. You define the keyword with the keyword name and the keyword implementation which was built for you. And then you append the trailing code and you put it all back in the source. And then this extract arguments from and the build implementation for are merely about 1,000 lines of code that do the actual hard work. And seriously, I do like you people. I'm not going to show you any of that, because that's not going to make your life any better. I promise you. So what does this mean? This means that when I write keyword debug, blah, 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 the keyword mechanism takes those components, rearranges them into a begin block like this. And what do we now have? Now we have a begin block, so this happens at compile time. We define a new subroutine, a new keyword called debug with a subroutine that's the callback. And the callback just says, take the source code at the point where you find the keyword, create a PPI document, and then extract from that whatever you said to extract from it. In this case, the ident and the block for the debug. And have you extracted that, then take the subroutine that you've built, which takes an ID and a block, and then just do whatever the code said to do. That didn't even change. You just return that, and the return returns from the subroutine, and so it puts it back in the source code. And that then means this gets rearranged to this. And with that tool, I was able to completely re-implement DOS at the next level up. And instead of having all of this code just for the method keyword, I could get rid of all of that code, increase the font size, which is the most important thing, put in a little bit of extra code saying use keyword declare. These are effectively now compile time regexes. Because this is all compile time, I had to give it another keyword called key type, which would do the compile time declaration of that. Declare a keyword called method. It takes these arguments and it returns this string, and everything else was the same. And now it's done. So it now takes a name, a list, some attributes, which are optional, and a block. The name and the attributes come from these declarations, so you can declare that what you want it to match after the keyword is something matched by a regex, if the regex can do the job. But of course, regexes can't do the job for everything. They can't do the job for complicated Perl code. So instead of that, you can use things like list and block. Where do they come from? They're actually just abbreviations for, I expect this to be a PPI thing. And it uses exactly the same names. You get the bits of the source code in those variables, some of which can be optional, so it'll just skip over them if they're not required. You do the work before, still 1,000 lines of code you're not going to see. You return the new source code, and you're done. And then the has and the class fit on the same screen. This is actually my only criterion for good code. Does it all fit on one screen? And so with that tool, my Perl 5 classes could be as pretty as my Perl 6 classes. So here's my Perl 5 class. You use DOS, you get all of these keywords, class, has, method, and so forth, and it's got all of the cool stuff in it automatically. So this would have been a really short talk if it had all actually gone that well. I hope you never believe speakers when they tell you how it all went just swimmingly and it was all exactly the way we expected it to be. Well, I have to say, up to this point, it did go that well. All my test cases worked and it was all perfectly fine. And then everything fell apart in literally a single second. So all my tests were working fine. And then I thought, right, I'm going to build my first actual object-oriented application using DOS. And I built it very quickly because the Perl 6 syntax is much nicer for declaring classes and so forth. It was all cool. And then I ran it and waited and waited and waited And exactly 950 milliseconds later, my code started running. Man, it was like running Moose. My simple little DOS set of classes took just under a whole second just to compile. And then, being a scientist, I thought, well, maybe that was an anomaly. What will happen if I add as many classes and methods and attributes again? I predicted, well, it'll be a little bit under 2 seconds. No, over 2 seconds. Turned out the runtime was exponential. This makes Hulk sad. So what's going on here? Why was this slow? Well, I tracked the problem down, and the problem was in keyword declare. And keyword declare was struggling with its performance. And why was it struggling with its performance? Simply because Adam Kennedy hates me. Here's Adam Kennedy hating me. You'll notice that the first thing that keyword declare does is it builds a PPI document out of the source. Now, note, this is not out of the source that's just the arguments to the method. This is the rest of the code file. It has to take the entire rest of the code file and build an entire parse tree for all of that. And then what does it do? It converts that declaration of a keyword into some code that looks like this. And what do you notice this thing doing? When that keyword comes up, it has to reparse the entire file in order to work out what the keyword does. So every time you declare a keyword, you have to parse the entire file into a tree of objects. And every time you use a keyword, you have to reparse the entire rest of the file into a tree of objects. And every time it's the entire rest of the source code. Now, I'm not blaming keyword simple for this, because that's just how the keyword mechanism is designed in Perl 5 since 5.12. And I'm not even blaming PPI for this, because PPI is doing what you ask it to do, which is, here's a whole lot of source code, give me back a representation of it. This is just an impedance mismatch. The keywords really only want specific arguments. The keywords know what they want. They want an identifier followed by a block or something like that. But PPI isn't capable of that. PPI's job is, here's a whole chunk of code, tell me what's there. And there's no mechanism in it, and believe me, I looked, where you can kind of guide it. It only parses what's actually there. You can't direct it in any way. So that was the problem. In other words, I had to parse the entire file, and then from that entire parse tree, I have to extract the bits that I'm actually interested in afterwards. So it's like the old US Marine motto. Parse everything and then let DOS sort them out. So clearly this was not a good approach. This was not going to solve my problem of time and performance. What I really needed to do was only look at parsing what the keyword actually expects and immediately terminate if I encountered anything else. There's no point reading the rest of the file if I haven't found an identifier. So what I needed was not something like a grammatical parser. I need something more like a regex. You know, with a regex, you say, I want you to match numbers, and then I want you to match a string, and then I want you to match this, that, and the other. And what happens if the regex fails on the numbers? It doesn't keep trying for the rest of it. It just says, no, that was not right, you're out of here, done. Like a regex does. Like a regex does. But of course, it would be totally insane to try and parse Perl using regexes. No one would think of doing something like that, because that's ridiculous. So of course, that's what I did. I added one more level of indirection. I hope you're keeping track. Created a new module. This module is effectively a partial PPI replacement. It is a recognizer for Perl in pure Perl. It is a Perl parsing regex, so obviously I'm going to have to call it PPR. And this is PPR. So you use the module and you get a single variable which you have to insert into any regex where you want to do this kind of nonsense. And once you insert that variable, then you get a whole series of named subpatterns. You're familiar in Perl with the fact that you can declare in a regex named subpatterns which you can then use to match. They're a bit like subroutines for regexes. It's a very cool technology. So I made regexes that would do Perl identifiers and Perl variables and Perl expressions and optional white space. So literally I could match has, optional white space, identifier, optional white space, variable, optional white space, look ahead and see if there's an expression with an equal sign. And now I can parse a has keyword and nothing else. Or I could do the same thing with method. The method has an identifier, a list, and then a block. And the question is, well, that's great, you're recognizing it, how do you get the information out? And you know how you get the information out, you capture it. It's not rocket science. So you capture it, and then you say, okay, the name, the parameters, and the body are just $1, 2, and 3. Or if you're using a modern version of Perl, do you know that there's now a variable that has all of the numbered captures in it, which is a much better alternative. Or you could do named captures, which would be even better. And it's not just for parsing keywords. If you wanted like a try, catch, finally construct, you could do exactly the same thing as well. Or here's something I actually did. I said, one of the things you can match is a Perl use statement. So literally what I do is I go through and I capture every Perl use statement that I match, and I match them globally against the source file, and I select out just the defined ones because there's a whole lot of regex captures inside this that aren't actually capturing anything. So if you get the defined ones out, then you have a complete list of what was used in this source code. So building dependency graphs and so forth with this, easy. Now I know you want to know how it works, because it must be simple, right? Well, it is. The entire module consists of 4 statements. All right, one of them's a very long statement, but 3 of them are very short. So here's the whole module. You declare the module, you set up a version number, and you use UTF-8, because it's entirely possible that the Perl code you've been given used UTF-8 as well. And then you just write a regex that matches anything in Perl. Trivial. I don't know why no one else did this before. So the Perl parsing regex just goes there. So maybe we should fill that in a little bit. So you write a 1759 line regex, which is about 53,000 characters long and has 123 of these separate little subrules all working together to parse Perl, plus 1 quantum singularity that I'm not quite sure why that's there, but has to be there. And you get rules for everything. A rule for an entire document, for a single statement, for a subroutine declaration, for an expression, for a comma list, for a binary expression, for a term, for attributes, for an anonymous hash constructor, for a comma. You get rules for everything. Now, the interesting thing about this is it turns out that it's not really that difficult to write a 1759 line long regex. I know it might seem like it could be difficult, but it isn't really that hard. You just do it line by line and you get things right and wrong, and eventually the whole thing works. Sleep, what's sleep? The problem is not writing 1759 line regex. The problem is debugging it. So I was about to start this process. I didn't know it would be 1759 lines, I have to be honest. And I thought, that's not going to be a problem, because I've already got a solution to that. I just need to add one extra level of indirection. Because I had written a module called regex debugger. Have people heard of regex debugger module? Okay, so I thought, this will be easy. When I get stuck, I'll just run regex debugger and it'll explain to me what's going on and why it's not working correctly. And that turned out not to work as well as I'd hoped. Because the version of regex debugger that I had at the point where I began this project couldn't actually debug anything that was in a QR, which made it a bit difficult. And it also, curiously, struggled with large regexes. And by large regexes, I meant 20 to 30 line regexes it was having trouble with. So 1759 lines, not so good. The other thing was, it would only run step by step. It would literally show you every step and not be able to jump over things that you weren't interested in. So I had to debug into every optional white space between every other thing. And when you're doing step by step for 100,000 steps, that's not a fun day. So before I could solve this problem, I actually had to rewrite regex debugger, pretty much from the ground up. So the version that's on CPAN now will handle interpolated QRs. It also, more importantly, has a step over as well as a step into. So you can just say, okay, I'm at a optional white space, I'm just going to step over it. I don't need to see it do the matching, it's not very interesting. It also has what every debugger should have, which is, I'm in this subrule, I don't care about this anymore, this is not where the problem is, just run to the end of this subrule. All kinds of other improvements, which made the 1759 line regex go from impossible to really, really easy to debug. So I can probably show you that. Maybe. That's not where I want to be. Be where I want to be. Okay, so here's a very simple example using PPR, regex debugger, and I'm basically just going to do try, Perl optional white space, and then a Perl block. So for those of you who haven't seen regex debugger, this is what regex debugger looks like. You get a representation of the regex, or as much as will fit on your screen. You get a representation of the string. You get told where you are, and then you can just literally step through it. So it'll say, am I at the start of the string? Yes, I am. Huzzah. Then it says, okay, what I'm doing, I'm trying this literal sequence. Did this match? Yes, it matched. Huzzah. Now, I can, at this point, say, do I want to jump into the optional white space? No, I don't. So I'm going to say, let's step over that. And now it's going through and stepping over it. It still takes a lot of time to do, but at least it steps over it. And it says it matched. And you can see it matched the white space down the bottom there. And now we can say, okay then, well let's step into the Perl block thing. And we can just continue on at this point and run it till we finished and work out where the thing's not working. So I'm not actually going to run that for you, it's not really interesting to see, but you can see that this now makes it feasible to jump in and jump out, just the way you do with the regular Perl debugger, into and out of subroutines, and you can step over it. And yes, you can set breakpoints if you want to as well. You can even put things in the code that set breakpoints for you automatically, like db single does, which is a cool thing as well. So that's pretty cool. Now, by the way, did you notice at this point, in order to solve getting has, I had to write dios, which means I had to write keyword declare, which means I had to write ppr, which means I had to rewrite regex debugger. And at this point, I realized I was in the middle of the plot of Inception. I was 5 levels down in the dream, except this was Perlception instead. So, I upgraded regex debugger. That made it easy to go up a level and implement 1759 line regex, which again, simple is perhaps not the word for it, but then the question is, well, does it really match Perl? Does this really, really do that? And the answer is, oh no, of course it doesn't. Only Perl can parse Perl. We know this for a fact. But it does it at least as well as PPI does it. And it does it for the kind of applications I wanted it for about 5 times faster, minimum, than PPI does. But that's not really a fair comparison, so we should put a star there, because it's not doing the same thing. It's not building a data structure, it's just extracting the bits for you. It does pass all of PPI's quite extensive test suite, and it also passes its own very much more extensive test suite of just under 500,000 tests. Because if you want to release something that you claim parses Perl, you better parse a lot of Perl with it first. Now, when you download it, it does not do the 500,000 tests. These are developer tests. I get away with a couple of thousand tests. So how did I test it? I simply turned all 1,730 modules in my various CPAN distributions into tests. It has to parse every one of those. And then I took the other about 3,500 Perl modules that I had installed from the CPAN just on my own system and took all of those and made them tests as well. And just for the hell of it, I put it all in one 57 megabyte test file. As you do. And you say, well, okay, so it obviously can test 2 million lines of Perl that you happen to have installed, but does it really handle the hard stuff? Well, the first thing I did was test whether it actually parses its own source code. And it does. And then just for malice, I got it to parse all of PPI's source code as well, which it does. It also parses much more interesting things. You remember Eridul's camel code? One of the very first and one of still the very best obfuscated Perl things? Well, it parses that perfectly as well. A guy whose handle is Blockhead said, I don't like Perl code that's got lots of punctuation in it, so he or she found a way of writing Perl that had no punctuation in it at all. This is a JAF done with no punctuation whatsoever, which is pretty impressive. You might be aware of Andrew Savage's Acme eye drops. And this is basically a meta module that takes any code that you write and turns it into this, which is executable Perl code. But very hard to recover the original behavior from. And yeah, it parses that. And it parses my favorite stupid module in the whole world, which is Karen Etheridge's Acme look of disapproval. Now what does Acme look of disapproval do? It installs a disapproval keyword, which is just the same as die or croak, basically. But you get the disapproval look. And of course, you can put a disapproval string in as well. And then for the ultimate test, I made sure that it also parses a piece of code that I wrote many years ago for the obfuscated Perl contest called self-goal. And most of you won't have seen self-goal before or heard my 3-hour talk on what it does. You did? Yeah, you did. Have you recovered yet?
Yes, I fully recovered.
Oh, excellent. I'm glad to see.
On the other hand, I'm here.
Yeah, you haven't learnt. Yeah. So this was my entry for all 4 sections of the obfuscated Perl contest a few years back. There were 4 different tasks and I just wrote one thing that did all 4 of them. This has some interesting characteristics. For a start, if you try and run it through Perl Tidy, it stops working. Its own structure is part of the code base, because obviously. Anyway, PPI parses this. Now, I'm not recommending that you go out and write yourself a 1759 line long regex that parses Perl. You don't need to, I've already done that for you. But I will say this about it. In doing this, I actually learned a lot about Perl. Now, I would have laid money that I knew most of the tricks of Perl, but I was entirely wrong. There were all kinds of things that I learnt that I hadn't known before. So I'd like to take you through a few of those things so that you can learn the lessons as well. The very first lesson is that you really shouldn't be implementing Perl parser as a regex. This is the lesson that I want you to take away. Don't do it. It will not make your life better. But the first useful lesson that I got from doing this implementation was not that greed is good, because we all know that, but that insufficient greed is not good enough. Because I told you that the reason that I started on this ridiculous project was that I discovered that when I ran my first DOS program, it took like a second to compile. And so you might have thought that when I replaced PPI with PPR, then things would get a lot faster and a lot better. And what I found was it actually took longer with PPR. Now, at this point, I had invested a number of years in this entire project, and for it to actually run slower was not a good day. I was not up doing the happy dance. So I went back and looked at it, and I ran into the debugger and tried to work out what the problem was. And the problem was, when I first wrote it, I wrote it something like this. A package declaration consists of a package, followed by necessary whitespace, followed by qualified identifier, followed by a version number, which is optional, followed by blah, 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 blah. And then an expression is a low precedence not expression, separated by a low precedence infix operator, separated by a low precedence not expression, etc., etc., and so on and so forth. And what I realized was that what was killing my performance, what was slowing me down every time, was every star and every plus. Because, of course, what would happen is it would fail to parse something, and then it would say, oh, maybe I can parse one less of this, and that will make it work. And it didn't. It just made it slow. It still ultimately failed. It was just now very slow. So what I needed to do was this. Now, I know this looks horrendous and terrible, and I just literally doubled the number of parentheses in this regex like there weren't already enough to begin with. But what I did here is I put these things around every call. These are non-backtracking parentheses. These say, if this fails, don't go in and try again by doing less repetitions or something. Give up immediately. And I did it down here as well. If you have a 0 or more repetition and you add a plus to it, then you make a 0 or more but don't bother backtracking repetition. That is, match as many as you can, but if you fail, don't try to match one less, because that's not going to make your life any better. And what this is really doing, if you go through the entire 1759 lines and put these in pretty much everywhere, is it's turning a non-deterministic finite state automaton into a deterministic finite state automaton, which means that the parsing goes from being worst case exponential to worst case linear. And that speeds up things enormously. Which brings us to this weird looking thing, the singularity in the whole regex. What this actually is a very special regex that has been written to match any possible Perl built-in keyword or function, but to do it without any backtracking. Now, interestingly, this is not actually necessary in very modern versions of the Perl compiler. I forget the number, it's probably around 20 or 22. You don't need to do this anymore because Perl automatically does this for you. But because this is supposed to run all the way back to 5.14, I needed to do this. And literally all you do is you match the first letter, and then you match the second letter, and you continue on, and you don't let anything backtrack. And this one change improved the performance more than anything else that I did. Because it meant it didn't have to go through thousands and thousands of alternatives every single time it wanted to find a keyword. Now, was I insane enough to sit down and write that by hand? Of course not. That would be madness. Dan Kagai solved the problem for us many years ago with a module called regex optimizer. And you just write the regex the way that a normal human being would write the regex, that is, just as a series of alternatives. And Dan's wonderful module takes that and turns it into that appalling thing that you saw, which I then just cut and pasted. Because who has time? So that was pretty cool. I also learned a few things about Perl that I hadn't known before. So, are you familiar with for loops? Yeah, this is not one of the things I learned about, except I did learn something about it. So the for loop, the old version looks like this, and nowadays we all use my, I hope, to give it a guaranteed lexical variable. Did you know that you are in fact allowed still to use our if you are feeling insane? And if you're totally off the wall, you can even use state there, which is frankly bizarre, but you can use it. You can also, in modern versions of Perl, do this. So in any version of Perl which is recent enough to have reference-to-reference aliasing, you can do this. Now, it's not interesting to do it like this, but this becomes interesting. When you have reference-to-reference aliasing, you can say, I want you to take this variable and alias each of the list of lists in this, and it's an array of arrays really, to that variable, one at a time. Which is very, very cool to do that. And of course you can do it with our, or you can do it with my. And from Perl 5.24 onwards, you can even put the slash in the same place. Like this. And these all have to work. And they all do now in PPR. Are you familiar with these functions? The autoload function and the destructor function? You've seen those before? Okay, so if you're using object-oriented Perl, an autoload function is the one that gets called if you call a method on an object and that class doesn't have that method. Instead, it just says, okay, I don't know what that is, I'll call this one instead. And the destroy is the destructor for your class. So it gets called when the object is deallocated and reclaimed. So that's all, okay, that's obvious. But did you know that on these two particular subroutines, the keyword sub is entirely optional? You can leave the sub keyword off and it still works. Not on every subroutine, just on those two. Are you familiar with begin and end blocks that execute at the beginning during compilation and at the very end after execution finishes? Did you know that the sub keyword on them is also optional? You can put one on them and they still work. Yes, you can have multiple ones and you don't get repetition of this subroutine name declared. It's incredible. Every one of these were things that I had to go back and fix in PPR. The first release of it, I completely forgot that that's a valid statement. And so some people's code broke. And not only is that a valid statement, that's a valid statement. What's that doing? That is an empty statement with a label whose name is underscore. Perfectly legal. You'd think no one would ever do that. You haven't looked at enough of the CPAN yet. Of course people do that. And they do this. It's an L, not a 1. And then they do this. And their code suddenly becomes illegal. That's a perfectly legal label. That's a perfectly legal label. That's not a legal label. That's the start of an unfinished match operation using colon as the delimiter instead of slash like sane people would use. Which brings us to the insanity that is parsing regular expressions. Valid Perl. Call the foo subroutine, parsing it the result of doing a match against the string bar with spaces in it. Perfectly okay. As long as you put a semicolon there, then it's legal. Or it can be some other operator, or it can be a quantifier, but you can't do that. No longer a regex. What's that? Yeah, you'd think so, but no, it's not. It's a syntax error. The only way to make that into division is to actually put parentheses on the calls. Final thing I discovered, Perl would be a much cleaner and smaller and more parsable and more understandable language if it didn't have docs. Yes. And Perl 6 here docs are better than Perl 5 here docs, but they're not good. So you say, what's wrong with a here doc? How hard is that to parse? You parse some expression, you see the here doc introducer, you find the terminator of it, you step over everything to the terminator, and everything's good. What's the problem with that? No problem with that. That one's easy. The problem is here docs can be stacked. You can have 2 or more here docs on the same line, and then the actual strings for them followed on afterwards. And what's worse, you can have other things on the line as well. So when you're trying to parse this with a regex, you have to say to the regex, all right, parse that, find that, jump over everything else and parse that stuff, then jump back, find another one, jump over the stuff that you already did, find the rest of it, jump back, do an entirely different statement, and when you get to the end of the line, jump over the whole thing and down to the bottom. And the regex says, no. Regexes don't work that way. We go left to right. We don't jump around back and forth. We ain't having this. So how do you parse these with a regex? By the most appalling and devious hack imaginable. You simply do this. You say, okay, we're going to parse this thing, we're going to encounter one of these, and I'm not going to go off and find the string that actually is terminated by the terminator. I'm just going to remember that there is supposed to be a string coming up at some point. And then I'm going to continue on parsing as if I'd parsed the whole thing, and then I'm going to find another one of these, and I'm going to do the same thing again. I'm just going to remember it. I'm not going to actually deal with it yet. I'm going to go on and I'm going to do whatever else I need to do. Remember, we're doing this in hierarchical nested regex subroutines. And then at some point, you're going to hit a new line. And when you hit the new line, that's when you have to see, are there any pending, unparsed here doc documents? And then you go through and you just parse them one at a time, and then you just continue on. Now, that might sound like a really easy solution, but regexes don't like having memories. They don't really appreciate you trying to give them memories. So I swear to you, I had to try 8 different ways of doing it before I found one that worked. And the problem was not that the first 6 or 7 didn't work, but the first 6 or 7 only ever worked on regexes up to 5.18 or regexes after 5.18. Because the regex engine was completely rebuilt in 5.18 and the mechanism for all lexical variables and backtracking and everything was completely redone, and the mechanisms are completely incompatible. And something that will work on one won't work on the other. And there was only a very small window where things worked on both. Yep, really. So that's a lot of fun. So here's how we actually parse a here doc now. You start off by looking for the introducer, then you look for the new feature of indented here docs, which is you're allowed to have a tilde there. Then you look for the actual terminator, which can be either marked with double quotes or single quotes or backticks or nothing at all in old versions of Perl. You find the identifier, you find whatever kind of quoting that there is going to be, you find the here doc terminator, and then you go in and create some global variables. This is the only thing that works on every version of Perl. Yeah, I know, it's horrendous and appalling, and that's what you have to do. And in order to do it right, you have to do it differently for every single string that is being parsed. So you have to know whether you're still in the right string or not. Once you've set up all those variables that tells it what to skip at any given point and what it's already seen at any given point, then you just do this. You say, all right then, if we haven't parsed up to the current position, then we need to do look ahead at this point. And then we say, and having decided that, we have now parsed up to the current position. And then you remember whether you needed to do look ahead. So then you match white space to the end of the line. You remember where you parked. You skip over anything that you already have parsed and should have skipped over. You keep looking until you find the here doc terminator. And then you update what you're supposed to skip by saying, now we have to skip this much extra anythings. No, I don't expect you to understand this. You can go and look at it in PPR source code if you want to. I would recommend not doing so. Your life is bad enough already, no matter how good it is. Okay, so, and of course, where do we find out the difference between these two positions? Because we remember the position up here, and we can re-get it down there. It's all very cool. Okay, so that's what you have to do. And then you have to completely rewrite your optional white space testing. Your optional white space testing now needs to know whether there is any possibility of skipping here docs. If there is no possibility of skipping here docs, then you can go into a very high speed white space matcher. But if there is any possibility of skipping here docs, then you have to go into a very slow matcher that skips over horizontal space or comments or end of line markers, or then matches a new line and you have to do that for every line. So you keep going round and round in a non-backtracking loop. And the really cool thing about this is it's not just in optional white space you have to do this. It's in necessary white space, and it's also in any other construct that can have white space in it. So it's in every set of balanced parentheses. If there's white space, there could be a here document. Yep, you can put a here document in the middle of a double quoted string, because of course you can. Or in balanced curlies or balanced squares or balanced angles, or in any other kind of quote like where it has opening and closing delimiters identically. In any of the places where a new line can occur, you also have to do the skip. Oh, and just for fun, also in a Perl format. And I forgot about the Perl formats. But fortunately, I was at the wonderful Perl conference in Amsterdam last year, where Marijn, who also hates me, here's Marijn hating on me, heard about this module and said, yeah, but I have an example that doesn't work. And his example was just insane. So, have a look at this. Here I'm doing print from a here doc, and there's the here doc, but it's in the middle of a format. And here's the format. And you think, okay, well, maybe that's not so hard to get right, but you haven't understood the genius that is Marijn. Because he didn't show me that example, he showed this example. What's going on here? Well, there's the format definition, and here are the arguments to the format, and those arguments consist of a whole lot of here docs with weird looking delimiters, and some of the here docs, here are the delimiters, and some of the here docs are double quoted delimiters, which means that they interpolate, which means you can put a variable inside them which has got a here doc inside it, whose terminator is the same as the damn terminator for the format. And that's how Marine's brain works. Yeah. Yeah. So in order to understand what he actually did here, here's a diagram of the nesting of these various constructs inside each other. And yeah, there's absolutely no reason why you couldn't have a nested format inside this as well. So he is the devil. If you actually download the PPR module, one of the test files is just entitled Marine is Satan. So, to sum up what I learned in doing this, you really shouldn't be implementing a Perl parser as a regex. So, having successfully implemented a Perl parser as a regex, I could finally go back up one level and re-implement keyword declare. So what did that look like now? Well, now, instead of the PPI-based stuff, I used PPR-based stuff instead. So literally what I did was I used PPR, I created a regex, which I'll show you on the next slide, and parsed the source code for what's available for any keyword, and put all my captures in named captures, which I can then just copy into a sensibly named variable, and then everything else was exactly as before. No differences at all. And here's the regex that I wrote. And again, it's not all that complicated. So again, I use PPR, and I use the various components of PPR to match strings and regexes and identifiers and quote likes and white space and blocks and so forth and things like that. And all I did was I said, okay, match an identifier and capture it as name, match a parameter list and collect it as params, match a block of code and match it as block. And so now back in this code, that's what comes back in the named variable, the named capture variable, conveniently known as %+ for readability. And then I just use those components in the 1,000 lines of code that I had previously that did the hard work here. And everything above that level in the dream was exactly the same as before. Except now the parsing is all regex based and directed and efficient for the task. It only ever needs to parse up to the first thing it didn't expect or to the last thing that it did expect. And it never needs to parse to the end of the file unless you put a keyword at the end of the file. It's about 10 times faster parsing these keywords on shorter files, and of course the longer the files get, the quicker it gets because the less percentage it's actually doing. Exactly the same API before, so at the next level up I didn't need to change DOS at all. And whereas before it was taking over just under a second to compile my first real case, it now did it in just fractionally over 100 milliseconds, which is fast enough that I said, sure, that's fine. Don't have a problem with that. And so now, instead of beautiful Perl 6 and ugly Perl 5, we have beautiful Perl 5 as well. And both of the brothers are just so lovely and beautiful and wow. They're fantastic. But more importantly, now Perl 5 has the power of Thor. Because now you can make keywords for Perl 5 as easily as you can for Perl 6. And I would argue at the moment actually more easily than Perl 6. Because the macro mechanism for Perl 6 ain't there yet. It's partly there, but it's not fully there. So at last, I had my 3 little words. And I want to show it to you actually running, because you've now put up with this for over an hour, and you better see some reward for your patience. So here is the typical kind of person and user inherits from person class done in Moose. Extends person, has password, last login, blah, blah, blah. And I'm just going to run it a little bit and do interesting things with it. And all it's going to do is, in fact, eventually print out today's date. Because that's all I made it do. And here's exactly the same thing in DOS. So the class is now just a 2-liner. The user uses person as its base class. It declares a couple of things. It makes only the methods it needs to make. The base code is exactly the same, and now it runs, but more quickly. But the cool thing was, that wasn't the end of the story. Because not only did I have DOS now working and working fast enough to be useful to me, now I had made the dream real. Now I had the ability to completely warp the entire fabric of Perl 5 space-time. Not just for DOS, but now at the next level down I had keyword declare. And so of course as soon as I had the ability to make any keyword, what did I do? I went crazy. Well, all right, crazier. Let me show you. Come on. Come up to the right place. There we go. So I wanted not just Perl 6 class declarations, I wanted all the cool stuff out of Perl 6. So Perl 6 has a loop. So I never wanted to write while 1 again. All I ever wanted to write was loop this thing. Perl 6 has a repeat while loop, which is like a do while but without the problems. Like you can actually last out of it if you need to. It has a for loop syntax where you just say for and then your list and then an arrow and then 1 or more variables, and it'll iterate through them 2 at a time if you give it 2 parameters. And if you give it 3, it'll iterate them 3 at a time, which is fantastic for iterating through hashes or through KV slices. It has a first block, which executes only the first time through the loop, and a last block, which executes only the last time through the loop. And I wanted it all, so I wrote Perl 6 controls. And now you run it, and it says, what animals do you want? I want cats and rats, and it does that, putting the parens around it in the first and last block. And you can do dogs and frogs, and there's nothing because there aren't any, but there are bats, and you can get the bats and so forth. So, you know, don't care about the code. I care about the fact that I could write it with Perl 6 constructs if I wanted to. And the other one I wanted was try catch. So, you know, there are only like 20 or 30 try modules on CPAN, and I thought what we really need is another one. But I wanted one that uses the syntax of Perl 6. And the syntax of Perl 6 for try catch is a bit unusual. You have a try block, but the catch is not after it, it's inside it. And the reason it's inside it is when you're inside it, you have access to all the lexical variables that were declared inside it. So if there's a failure inside it, you can still refer to those lexical variables, which is kind of cool. And yeah, it works. Blah, blah, blah. Who does testing? Who tests their Perl code? I wish I was seeing more hands at this point, but you know, whatever. So have you used the OK test, where you just say OK and then a Boolean expression, and if the Boolean expression turns true, then it will print OK, and if it'll print not OK? This is really annoying, the OK, not OK thing, because you never know what the problem is. You don't know why it failed. And that's why we have test more with like 300 different methods in it that you can use to get more information, but they're kind of awkward as well. So I said, what I want is an OK keyword. And that keyword will take an expression and it will analyze the expression, work out what test is being done, and it will give me error messages that reflect what test is being done. So you've never seen a test file like this one. Check this out. So when things fail, it tells you it failed that test, and it tells you this is what the variables were and what the values were. This makes testing like 1,000 times easier. And every test you just do is OK and whatever the test is, and it just goes through and analyzes the actual source code of your test, even really complicated things like this appalling thing. And it says, this failed because that was wrong and this one was wrong. And how does it do it? It does it with keyword declare. And what does the keyword do? It uses PPR again to extract from your expression what the components were. And then it uses some of the modules that look up lexical variables in your scope to work out what the problem was. And then I thought, why can't I bring the benefits of Java into Perl as well? Now, for those of you who are not familiar with the benefits of Java, well, yeah, there aren't any, but you can do some things in Java that you can't do in Perl. For example, you can make a variable that is of type integer, and which throws exceptions if you try and put anything other than an integer. And you can make constants of a particular type, and you can do lets as well, and then you can run it, and you get error message saying, look, I can't assign this to the constant bar because it's of the wrong type. So you go back and you say, well, the easy way to fix that is to make it not a constant. And then we run it again. Ooh, it doesn't like something there. What did it? Oh, no, sorry. Sorry, make it a var instead. And now it says bar can't be assigned to because Fred's not a number. So again, you can fix bar by removing the type on it, and now the whole thing works. All right, so maybe you don't want to have Java-like variables in your code, but you can now. Oh, it gets worse. So I thought, Perl has a my and an our declarator, but it doesn't have a your declarator. So I thought we better have a your declarator. So I made a your declarator, and the your declarator takes a variable but tracks it. So every time you assign to it or modify its value in any way, you get a report of the change in value, the line at which it happened, the variable which changed, and what the new value was. And this is actually kind of cool when you want to track down where your variable's going horribly wrong. You just change it from a my to an our, to a your, and it all works. First person to second person, now you get a report. And I thought, the other thing the world needs, and it doesn't have enough of, is modules that dump out data structures from Perl. Because there's only data dumper and data dump and data show and data dump easy and data, blah, blah, blah. I thought we need another one. So I made one called data dx. And it gives you a dx keyword, and you can put any variable or any expression, however complicated, after the dx. And what you get out when you run this one is it actually shows you the line and the file and the variable and what value is in it at that time, or the expression and what value it's equal to. And that is actually useful. It makes it a heck of a lot easier to see which one of these things is going wrong. And I thought, well, I might as well do something with the UTF-8. So if you use UTF-8 as well, then you can say d sub x. And yeah, it still works. Like that. And then I thought, well, why shouldn't I bring the benefits of other languages in as well? And I know that you know about the inline family of modules, inline C and inline Java and so forth. Well, that's pretty cool, but I didn't like the way the interface worked. It kind of was a bit tricky and hard to use. And I thought, what I just want is, I've got begin blocks and end blocks. Why can't I just have a Python block, where inside that block you just write Python code? So I wrote a module that does exactly that. Inside that block, you just write Python code. And the Python code just works. And if you can have Python, why can't I just have executable Latin? Because there's already a module on CPAN that will turn executable Latin into something useful, so I said, why not have that? So that's what I did. And now up the top here, I'm actually, the greatest common denominator function was implemented in Python. Here it is there, greatest common denominator function. And the primum function, which tells if a number is a prime number, as you can obviously see, is implemented in Latin. So you run that, and it just runs. Obviously. Simple. And then I did something that might actually be useful. So I apologize for this next thing in advance. If you don't want to hear about it, just cover your ears and go la 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 la, and you won't know about it. The last couple of years I've been doing a lot of teaching of people how to go from imperative code to functional code. And one of the great advantages of going to a functional style of coding is that it's really easy to refactor things. You can literally just cut a piece of code out, put it in a subroutine, put the call to the subroutine in the same place, and the thing's done. And so I would show people how to do this, and people would say, yeah, that's really cool. I might start using more functional styles of coding for that. And then I realized it's really tedious to cut a piece of code out, put it in, put a subroutine around it, and then put the call back in. And I thought, surely that's something that my editor could do for me. Yeah, if it can only parse Perl. Oh, hang on a minute. I know something that can parse Perl. So I wrote this. This is a little bit of imperative code. We're not yet at the functional code. It takes a list of keys and sucks out all the ones that have the word heat map in them, and then sorts them by a very complicated sort, and then extracts the corresponding values in the sorted order and prints the whole thing out. So when you run it, you get basically these numbers. Doesn't matter what they mean, that's the output of that thing. So the idea was, well, that's really horrible and ugly code, and what I'd really like to be able to do is basically just select a chunk of it that I don't want to see anymore and say, hide that away from me, would you? So I set it up in my editor, so I hit Control R, and it says, what do you want to refactor that as? Call that nice sort. No, spell it right. Nice sort. Okay, what do you want it to return? Well, what could it return? Well, here are all the options of what it could return. I don't actually want it to return any of those, so don't return anything. And now, of course, the code stops working immediately because there's nice sort there, but there's no actual definition of nice sort. But of course, what it's also done is put in one of the registers the definition of nice sort, which is down here. And we don't have the heat map. Why don't we have the heat map? Because I'm supposed to be returning the heat map. Okay then, let's do it again. Let's go back and say I want the same thing selected, call it nice sort, NS for short. What do I want it to return? I want it to return the heat map. Okay, so return the heat map. Okay, so it now returns the heat map. I better declare the heat map. My heat map, heat map equals that. Install the subroutine, and it runs again. So I didn't have to work out what variables to pass into the subroutine. It analyzed the variables and worked out what the local variables were and what the global variables were, and passed the ones that it didn't already have in, and returned just what was necessary. The cooler thing about this is if you're doing it with functional programming, then it gets a whole lot easier. You literally just say, I want to get rid of that ugly sort. You do that, make it num sort, and now it's num sort. And the only problem is it doesn't know what num sort is, so if we install num sort, now it just runs again. So literally, in that particular instance, it identified the fact that this was pure functional code, and it didn't bother asking me for return values because it knows that with a pure functional code, you just return the result of whatever you were factoring out. And then you can repeat the dose as necessary. So we could take these 3 lines and say factor that out, smart sort. And in this case, it's not entirely sure what to return. And again, we could just get it to return nothing. And then we need to install smart sort, like so, and away we go. So that's a module called Code Refactor. It's still undergoing a little bit of testing. It's not quite there, but I'm hoping to have that up on CPAN in the next month or so, with automatically a hook into Vim. And if people send me hooks for other editors, I'll certainly include them as well. But I ain't writing an Emacs hook. So, in other words, keyword declare gives me the ability to change the Perl 5 language and add things that just aren't there. And to do it in a way that I can do in 10 or 15 lines of code. Now, is that performance going to be the same as if it was built into the language? No. But what I think is, with something like this, you can actually prototype new features of Perl in a way that doesn't actually change the language, and if you like them, you can then implement them in the actual core instead. That, of course, is built on top of PPR, which in itself is incredibly useful. The thing I use PPR for more than anything else is when I want to skip over white space, but I don't want to have to deal with skipping over white space that might consist of comments or also pod, which I didn't show you, but pod can be white space as well. And I just say, look, I'm just going to use regex grammars, and all I'm going to do is say optional white space at this point. I know exactly what everything else is. I don't need anything complicated, but the white space could be anything. So I just have a module that does that. That's built on top of a new version of regex debugger. Even if you don't want to use any of these tools, regex debugger will make your life less painful if you ever have to use regexes. And all of them were used to build DOS and Perl syscontrols and test expression and DataDX and code refactor, and all of them except the last of them is on CPAN now. So my hope is that you will use these tools and these meta tools and maybe even these meta tools and possibly even the one meta tool, and you will go out and you will steal things from Perl 6. And you'll steal things from C and from Python and from JavaScript and from Haskell and from the Roman Empire. And that this newfound power, if you use it for good and not for evil, will make you love Perl 5 exponentially more. So thank you very, very much for coming and listening to that madness. Go and try some of the modules. They're crazy, but they're also useful. Thank you. Any questions?
Where did the exponential blow-up go? Was it just solved by the greater question mark?
No. The exponential blow-up in the original version was occurring because every time you encountered a keyword or a keyword definition, you basically had to go through and PPI the entire rest of the file. So every time you added a keyword, you effectively doubled the parsing time, or at least n on 2 doubled the parsing time.
Did you just speed that parsing time up?
No, because the point is that PPI had to parse all the way to the end of the source code that you're given, whereas PPR only has to parse as much as it needs to detect the components of your keyword. And that's where the difference came from. Plus the fact that PPI is building a whole series of Perl objects, a whole lot of hashes and so forth in a tree structure, and PPR doesn't do any of that. It literally just captures the bits that you said to capture. And that's where the exponential blow-up goes away. It's okay. I'll tell you an interesting... I'll take a question first.
Yeah. I was wondering why, for the built-ins, the singularity expression,
Uh-huh.
why did you use a hash with all the built-ins as keys and basically just grab a word and see it is in that hash?
Could I do that? Yeah, I could probably do that. I don't know. I don't know whether that'd be faster or not, but it'd be interesting to try it. I might give it a try and see if it speeds up anything or slows it down. That's a cool idea. I'll try that. Thank you. You know, I was telling you about Marine and his evil, appalling HereDoc thing. Before Marine showed me that code, the regex was only 1,100 lines long. It actually added something in the vicinity of 600 lines to make the whole thing work. The cool thing was, I showed this at the Amsterdam Perl conference last year as one of the early keynotes. And then in the first set of lightning talks at the end of the day, Marine got up and said, yeah, it's all very good, but it doesn't do this thing. And spent 5 minutes explaining his evil brain to everybody else. And about half the people said, yeah, it doesn't do that thing. It's probably a good thing it doesn't do that thing. But of course, I'm sitting in the back there and I'm thinking, it doesn't do that thing. So I grabbed the code and I basically spent the entire all-nighter the next night just fixing it and adding those 600 lines of regex. And then the next lightning talks the following afternoon, I got up and gave the lightning talk where I said, you know how it didn't do that? Well, now it does. So that was very cool.
That's why my comment is need sleep.
Well, exactly. Sleep, overrated. You don't need to sleep if you can code. Okay. Can I suggest to you, PPR is really something that's worth having a look at. You might find uses for it that you weren't really expecting. One of the things that's on my to-do list, like my to-do list is not ridiculous, is to rework text balanced. You know the text balance module that a lot of people use to do some of these kinds of things? It would be a heck of a lot easier with PPR at the back of it, especially the bits that purport to parse blocks and so forth. So what I want to do is not change the interface because people rely on it, but just make the back end a lot more reliable by switching into PPR when they need it. So I'm hoping that that might be something that I do in the future. But you'll find something that you want to do in manipulating source code, in counting things, in finding things, and PPR makes it really, really easy as long as you understand regexes. Okay. Thank you for coming. Thank you for bringing me here. I really appreciate it. I'm looking forward to spreading this kind of mayhem and dismay through the rest of Germany as well. It may be the end of the Bundesrepublik, but you know, it couldn't last forever. So thank you again.